Okay. Number 6 is x equals a number. So go out on the x axis to that number. And make a vertical line. I have a question. What is the slope of a vertical line? I heard it, undefined. So in this one, the slope is 0. On this one, the slope is undefined, just, checking stuff. Okay. Number 8. Slope equals y2 minus y1 over x2 minus x1. This one's got all kinds of negatives in it. So 0 minus -2 is +2. -2 plus 3 is 1. And this problem is sad because they did not give us the y-intercept, so we actually have to do work. No. Which point do you like better? -2, 0? Okay. Cecilia, were you like at the front of the school? Were you like, okay. Did you know that we had a fire alarm and we were all out on the field until just like 5 minutes ago? Oh, see, okay. Sorry, I didn't mean to be weird. I just like didn't want to mark you tardy if you were stuck at the front of the school and they wouldn't let you go. I would rather be in the car too. Probably warm in there, I'm thinking. Okay, 2 out of 3 done. Scooch down to number 13. I know it's weird, it's out of order. While you guys are doing the digital escape today, I want to be able to project the warm-ups 11 and 13 because they will actually help you do your digital escape. So I wanted to have one example of a parallel and one example of a perpendicular for you to look back at. So that's why I want to do number 13 and not number 12. But this one says perp. So here's your perp symbol, means 90 degrees. And a perpendicular slope to this. So this is the slope, but what is the perpendicular slope to that? Does anybody remember what we do to get perpendicular? Nobody remember? Yes, I flip and switch the sign. Okay, so what would the flip of 1/2 be? 2, and then switch the sign makes it -2. If you want to, down here you could go 1/2 goes to 2/1, which goes to -2, and the -2 being that it has to switch the sign also. So there's your flip, and then there's your switch sign. And x is -4. Y is 5. Y equals mx plus b. Two times 4 is 8. Okay. All of the classwork that we're doing today is in your packet. There is nothing in your notebook today. So you can just leave your notebook aside. Look in your packet for the page that has that like big triangle looking thing, star looking thing at the top. I think it says 360 or 62. 62? Okay. Okay. So we're going to do two things. We're going to do 62 and 64 on this, and then we're going to do something on the shapes page on the next page on the other side. Um, First, does anybody remember what the definition of a polygon is? Closed, a closed shape. Yep, closed. And then there's one more thing. No curves. It has to be a closed shape made of all straight lines. Does this count as a closed shape with all straight lines? Yes. Can this figure be rotated onto itself? Trace the shape on tracing paper and test your conclusion. If it's possible, where is the point of rotation? I don't think we really need to do tracing papers here. Just turn your packet until you get the same shape again. There it is. There it is. Okay, where would the point of rotation be? Yes, the center of the shape. So put a little dot there as close to the center of the shape as you can get. Okay, now I have a question for you. This is an advanced question. How many times can you rotate this around and get the same shape? So what is the degrees that it takes to get it back to itself? Okay, if the whole way around's 360, how many different times can I make this shape when I turn it around? Here's 1, 2, 3. Okay. So if you take a full circle, divide it into 3 equal pieces. Yeah. Yes. Oh, thanks. I really didn't notice yet. I missed you. No more leaving. Okay, Jessica claims she can rotate all polygons in such a way they will not change. How does she do it? What degrees can you rotate something so that it will always be the same as it was at the start? 360, right? So if you go all the way around, it's always going to come back. What else? What else works besides 360? Where are my skateboard children? They always know all the multiples of 180. And what else? 360, or what if she went 2 times around? What would that be? 720. A dot, dot, dot there. She could go 3 times around. She could go 4 times around. Since all polygons can be rotated 360 degrees without change, it is not a very special quality. However, the polygon in part A above was special because it could be rotated less than 360 and still remain unchanged. A polygon with this quality is said to have rotation symmetry. That is what we're working on right now, rotation symmetry. But what shapes have rotation symmetry? Examine the shapes on your 3.1.5 resource page and identify those that have rotation symmetry. Okay, so flip the page over. And these are basically yes or no questions. Can you rotate this something other than 360 and get the shape back to itself? Okay, so starting with the hexagon, and you guys can, we're just gonna write yes or no underneath them. So if you're already going ahead, it's fine. But what if I rotate here? Did I get the shape back to itself? Did I? Yeah, okay. What about this guy? Can I rotate this one and get it back to itself other than all the way around? No. What about this guy? What if I turn him all the way upside down? Is he the same thing as he was before? Yep. What about the trapezoid? Nope. Equilateral triangle? Yes. Square? Definitely. What about this dude? No, can't do it. Circle's my favorite. Will a circle work? Yeah, totally. Rhombus? Mm-hmm. What about this guy? That's a no. What about this guy? Okay, so take a look at how he is. Stand it up this way. Is that the same thing? Yes, it is. And definitely on this one. Okay. What shapes on the resource page have 90-degree rotation symmetry? That is, which can be rotated about a point 90 degrees and remain unchanged. So we're looking specifically for ones that we can turn on their side. And it's the same thing. Try me attack it sideways. Is it just the square and circle? I think it's just a square and circle. Okay, now 64. We're going to do two things to 64. We're going to work on rotation symmetry again. And then we're going to start to work on reflection symmetry, which is the last thing we're going to do on this, on the page on the other side. If you don't have a straight edge, you might want one for this part. Okay. So first thing I want you to do is count the sides. How many sides does this thing have? 10 sides. Okay, next question, fun question. What is the name of this thing? Yes, please. Yes, it's called a regular decagon. And the reason that it's regular is because all of the 10 sides are equal. Next question, does it have rotation symmetry? Okay, you're like, everything has rotation symmetry, Mrs. Tava. Okay, does it have special rotation symmetry? Something other than 360? Yeah, it has a lot of different rotation symmetries. But what's the smallest amount I can turn this and get it back to looking like this? Yes. Close. Yes. 36. 360 divided by 10. I don't know why I was thinking it was more than that. 36-degree. Okay. Now what I want you guys to do is tell me how many lines, this is switching topics. We're done with that topic. How many lines of symmetry are in this picture? Lines of symmetry, meaning if I folded on that line, it would match up. There's one line of symmetry. Two lines of symmetry. How many are there? This would have been a good picture for me to draw my spider web on. And my cute spider with his googly eyes. Okay, so is that it? Are there 5 lines of symmetry is my question? Is the answer 5? Unfortunately, no. Do you see that there's more of them down the center of each side? How many are there? I got 10. Do you guys get 10? Okay, now I want you to flip to the other side and work in your group, talk to each other, say hi, how are you doing? And draw in the lines of symmetry in the shapes. It should take you 10 minutes or less. Oh, except for the circle, that one has infinite lines of symmetry. You can just shade it in if you want. Group back here was so close to talking. So close. They almost did it. There was like a little brush fire started, but then just burned out. In my group, I'll say something like, I'm just interested in why the square has diagonal lines of symmetry, but the rectangle doesn't. Why doesn't the rectangle have diagonal lines of symmetry? Wouldn't that be such a fun topic for my group? All right, everybody, when you're done, flip to the digital escape page. And then you guys can grab your Chromebooks and go ahead and get onto the digital escape. There is one part of it though that I need to teach you how to do. So go ahead and grab your Chromebooks if you want, get into the digital escape. I'm gonna project it up here also. What was the easiness level of my symmetry business? I like it. Okay. Okay. I need you guys to find your puzzle 3 box. And I'm going to take my ruler and break it up into 4 pieces because I'm a nerd and that's what I do. And on number 1 and 4, what they want you to do is find the X and Y intercepts, but I think that this is, there's an easier way. So write down these equations in your, this is puzzle 3. No, I lied and I just put marks in my puzzle. It's fine, it's fine. Puzzle 2, not 3. Okay, puzzle 2, not 3. Write these 2 down. So in box 1, I'm going to put negative 4x plus 2y equals 8. And in box 4, I'm going to put 3x plus y equals 1. And this particular problem said parallel, and this particular problem said perpendicular. So I'm just going to put the little symbols for parallel and perpendicular um, in the spots. There are actually a number of you that already know how to do what I'm going to teach you. I'm going to teach you how to solve for y. It is such an easier thing to do in this problem than find the x and y intercepts and then find the slope and then flip the slope and stuff. Okay, so on problems like this, when they give you standard form, first move the x thing over. So undo whatever's in the front. Step 1, undo whatever in the front. I had negative 4x in the front, so I added 4x to both sides. This gives me 2y equals, okay, now pause right here. These two things are not like terms. This would not be 12x. Do not write that. That's not what that is. You want it to be like mx plus b, so put the 4x in front and then the 8. Are you picking up what I am laying down here? Okay, now I have 2y, so divide everything by 2. And you have y equals 2x plus 4. Okay, what is a slope that is parallel to the slope of 2? 2. Okay, let me say that again. What is the slope of a line that is parallel to a slope of 2? 2. Okay, so let's go back to the puzzle. Which one of the answer choices has a slope of 2? Positive 2. D. Okay, so the first code letter is D. You're on puzzle 2. Okay, now let's go do number 4. And there's going to be more of these. I think there are a couple in puzzle 3, so you'll get a chance to practice this, but you'll have this next to you. So undo the thing in front first. And this one is lucky. It's y equals -3x plus 1. You don't have to divide by anything because they already have just y, so you're done. Okay, now here's the most important question. What would the slope of a line be that is perpendicular to -3? Perpendicular. Positive 1/3, right? So the perpendicular slope, flip and change the sign. So take the -3, flip it, and change the sign. Okay, which one of our answer choices has a slope of 1/3? Positive 1/3? B. Okay, remember that's 4, so put that on the end. I don't really think that there's any work that you need to show for puzzle number 1, by the way. Did you guys look at it already? You just say if it's parallel, perpendicular, or neither. Okay. I'm going to give you the rest of the period to work on this. Do you guys know what the homework is? It's a worksheet in your packet that just has different transformations. That's it. There's 12 of them. Rotate, rotate, translate, translate, blah, blah, blah. Okay, come ask me for help if you need it. I am going to leave the warm-ups up on the screen because when you get to the puzzle part where you need the algebra, you're going to want to look at this. Will you have a 9 there? That wasn't your question. But the letters are supposed to be A, B, or C.
Oh, I put T on it.
Oh, I see. Oh, so it should be C, A, C, B. Oh my God. I don't. I can't. I can't do it. I can't.
It's okay.
I can't. I think it. Yeah, try.